Hello everyone, my name is Shamanavath and I welcome all of you once again to the series of quadratic equations. We are in part 2 of lecture number 7. In the previous lecture, that means lecture number 7, part 1, in previous video, we have seen how to solve a third order equation or a cubical equation. In today's lecture, we will see how to deal with the roots, the way we have solved some questions with roots, sum of roots, product of roots in our lecture number 5. Yes, you can see on the screen lecture number 5. So how to see sum of roots and product of roots for cubical equation. So let's get started. General form of cubical equation, we have seen that we have solved a couple of them in the previous video, which is ax cube bx square cx plus d equals to 0. That's a general form of cubical equation. What is this? A general form. This is a general form of cubical equation or third order equation. And here I have something for you, this one. Here, this one is the cubical equation in form of roots. This is cubical equation in form of roots. Cubical equation in form of the roots. So I am considering the roots to be alpha, beta, and gamma. Yes, this is gamma. Okay, like 3 symbols. I need to take some, I don't want to take ABC because ABC I have already used to express the general form of quadratic equation, general form of cubical equation. And here, this, that's why I need to use some other symbols. So better off taking some Greek symbols. Here, alpha, beta and gamma, yeah, as the roots. Okay, you remember roots means what? Values of x when you solve the equation. So if roots are alpha, beta and gamma, then we can say x cube minus alpha plus beta plus gamma x square plus alpha beta beta gamma gamma alpha x minus alpha beta gamma equals to 0. Don't get scared, you don't have to by heart this. Do you remember for square equation, as in the quadratic equation, we have seen the equation in form of roots. Let me remind you that. That was x square minus alpha plus beta x plus alpha into beta equals to 0. Now understand the similarity here. For square term, look at this. Square term, first term is x square. Second term x power 1. Third term is constant. Yeah, look at only x here. Similarly, in the cubical equation, you see x cube, then x square, then single power of x and then constant. Fine? Yeah. Second thing, you can see the pattern. The first term here is plus, positive. Second term is negative. Third term is positive again. This entirely is one term, okay? Don't get confused. So first term positive, second term negative, third term positive. Same here, first term positive, second term negative. This entire term, let me change the color. This is the entire term, negative. Then you got positive term, this entire term, positive. And then again you got negative. So positive, negative, alternate. You start with positive, be positive. Now, what about the roots? Look at that. First term, no roots. Second term, you take one root at a time. Alpha plus beta plus gamma. One root at a time. Next term, you take 2 roots at a time and make all the possible combinations. So if you take alpha, beta, gamma, all the possible combination, make with all possible combination with alpha, beta and gamma. So alpha into beta, then you have beta into gamma, and then you have gamma into alpha. Yes, this is not y, okay, this is gamma. gamma into alpha, right? So these are the three possible combination, and you make all the combination, add all of them, write that as the coefficient of x, and the next term is what? Take all three roots. So alpha, beta, gamma, product of all. Same thing you are following here also. See, no roots, take one root at a time. So alpha plus beta. Take two roots at a time, alpha into beta. Yes. Now there are only two roots. That's why there is no further terms in this square equation or quadratic equation. Clear? Okay. Think about it again. Let me write this for you again. So for cubical term in terms of roots, look at that. Definitely has to start with x cube with positive sign. Plus minus sign are alternative when you write in terms of equation in terms of roots. So the next term has to be negative. Take one root at a time. So alpha plus beta plus gamma, and then this is x square. Okay, next term this power of x is 2, definitely. X cube, x square, x, and then constant. Next term, what should be sign of the next term? Yes, absolutely right. That has to be plus minus alternate. Now you are going to take two roots at a time. That is alpha beta, then beta gamma, then gamma alpha. It's not y, okay, it's gamma, gamma rays, yes, into x. You got x square here, so now this should be x. It was positive term, so next term has to be negative. Then take all the roots at a time, alpha, beta and gamma, and that's equals to 0. Fine? You don't have to by heart. I hope you can understand this. If not, please revise this part of video. I have made it very easy for you to understand. If you revise this part of video, you will understand how do you write the cubical equation in terms of roots. Okay. Now, in quadratic equation also we have seen sum of roots, product of roots. We can try here also. So, if you compare this cubical equation in terms of roots and a general form of equation, which is ax cube plus bx square plus cx plus d equals to 0. And here if I want to see the product of roots and sum of roots and so, how do we get it? What do we get it? Not how, what do we get it? So here I can say, comparing this, alpha plus beta plus gamma can be said to be, this you get the square term, can be said to be what? Minus b upon a, sum of roots. Same as the square term, right? Same as the quadratic equation, sum of roots minus b upon a. Product of roots, yes, you are right. Product of roots here, alpha, beta, gamma, the constant term, and here constant is d. So alpha into beta into gamma, product of roots, that's equal to minus d. Here you got negative sign and here you got positive sign. That's why negative. Minus d upon a. Minus d upon a. Yes, you're right. Minus d upon a. Correct. Then you have sum of product of two roots at a time. Sum of product of two roots at a time, as in alpha beta, beta gamma and gamma alpha equals to this one. And this, if you compare with x power 1, so here you definitely have, see, both are positive, so I will just write c and divide by a. So that is c upon a. Note this part, it's important. Note this for cubical term, and don't by heart, please don't by heart. Understand, sum of roots minus b upon a, product of roots minus d upon a, sum of product of two roots at a time, c upon a. Yeah, and note this general form of equation, that's also important. Cubical equation in form of roots, that's also important. So 1, 2 and 3, these three you should note. Oh, by the way, are you using pen and paper while watching my videos? Yeah. If not, then you have to. If yes, thank you so much. You're following my instructions. Thank you. I'm really happy to see that. Okay. Fine. Now see some applications of this. Sum of roots and product of roots. Let's see some applications of this. Here you got okay, find the sum of square of roots for this. Sum of square of roots. That means if I take the roots of cubical equation as alpha, beta and gamma, here sum of square of roots has to be alpha square plus beta square plus gamma square. This is what we need to find. But well, here you don't see square, right? Here you see just sum of roots, product of roots, and this way. So to express this in form of sum of roots and product of roots, you can use some formulas, algebraic formulas. Yes, algebraic formulas. A plus B plus C whole square equal to A square plus B square plus 2AB. A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Now see how am I going to use it here. So instead of ABC I have alpha, beta, gamma. So can I say this is your alpha square plus beta square plus gamma square, and if I take this remaining part to the other side, see how it will look like. Okay, I will not write extra steps, please. I hope you are following this. So modifying this formula, I can say A square plus B square plus C square as A plus B plus C whole square minus 2AB minus 2AC minus 2BC minus 2CA. Right? Don't wonder how did I find this. Come on, as I said, this is concept builder video. Come on. When you're going to practice more and more, you will be able to link how and where and which formula do we need to apply. Take minus 2 common. What do you have here? AB plus BC plus CA. Now look at this ABC as alpha, beta, gamma. So I can say alpha square plus beta square plus gamma square here can be said to be alpha plus beta plus gamma. You have to, write you need to write, please help me out in this. Write in comment box. Tell me, when I'm going to solve the exam questions, the past year questions or up to that difficulty level question, do you want me to write all the steps? Trust me, it's not a good practice. For when you solve the past year papers or level of difficulty 2 and 3, you should skip steps. Okay, more steps, more time, less marks. More steps inversely proportional to the time you take. More steps, less time. No, directly proportional. Right, directly proportional. More steps, more time. Yeah, more steps, more time. And more time, you're going to attempt less number of questions. Yeah, so make sure that you avoid writing extra steps when you solve by yourself. When you are learning, yeah, of course, you can write all the steps. That's fine. So alpha, beta, beta, gamma, and gamma alpha. Yes. Now, so if I have sum of roots and if I have sum of product of two roots from the given equation, I can substitute and find what question said, what question asked us to find. Yes. So shall we go ahead? Shall we try here? Let's compare this equation. Let's compare this equation with equation in form of, or equation in general equation. Compare this equation with general equation, and then I'm going to use this here. I will see what is the value of A, B and C and D. Yeah, you got A is 1, B as not 4, minus 4, C as plus 1, d as plus 6. So alpha plus beta plus gamma, sum of roots as we discussed, sum of roots minus b upon a. Yes, minus b upon a. Okay. Yeah, minus b upon a. Minus b. So what is minus b? What is b? B is minus 4. See, b is minus 4. Yeah, b is minus 4 here. So minus of minus 4 upon 1, b minus b upon a. Then sum of product of two roots at a time. That means alpha beta, beta gamma, gamma alpha, that was equal to c upon a. Do you remember? Yeah, c upon a. What is c here? C is coefficient of x, that is 1, and coefficient of a is what? Coefficient of x cube, that's also 1. This is 1. This is what? Plus 4. Now, can we substitute here? Look at this part and substitute here. Alpha plus beta plus gamma is plus 4, and alpha beta, beta gamma, gamma alpha is 1. So I will get alpha square plus beta square plus gamma square as plus 4 square minus 2 into 1. That is going to get me 16. Yes, plus 16. Negatives to the power even is positive. Minus 2. That is what? 14. And this is your answer. This is your answer. Don't find this to be lengthy. Come on. I have to explain this formula. That's where I have added some steps here. Otherwise, now assuming alpha, beta, gamma, with 3 roots, that's what we assume all the time. So no worries. What do we need to find out that we should write so understand, so we can do some back calculation which formula to use. If you are comfortable with the formula, you can directly write alpha square plus beta square plus gamma square as this formula directly. And by comparing the given equation with general form of equation, you can find sum of roots and sum of product of two roots at a time. Substitute here and get the answer. Fine. That's one of the application. Let's see some more applications. Come on. Yes, we got 2 more questions. And please help me to not write extra steps. And how will you help me? By going through the previous part of all the videos and making notes. Yeah. Okay. Question is concept builder video. Next question. If the equation is this, has all positive roots, then what are the values? What is the value of a? The a could be what? Now understand this. You need to see how do you come to this conclusion. I have given you all the tools. I have given you the cubical equation in form of roots, general form of cubical equation. Now you need to try all the tactics to find this. Yeah. Pause the video, try this question. Well, now a here, that is coefficient of x. If you look at the cubical equation in form of roots, let me help you here. Cubical equation in form of roots, this one. The a, which is the coefficient of x, right? And question said all the roots are positive. So why are they saying all the roots are positive, all positive roots? It means when you see alpha into beta into gamma, that is supposed to be a positive value. Okay. When you see alpha plus beta plus gamma, that should also get you a positive value. Now when you actually compare, see here alpha beta gamma constant term, so minus alpha beta gamma is equal to minus 6. So alpha beta gamma should be equal to what? 6. See, there is no a here, so we can directly compare. The coefficient of x cube is 1, so I can directly compare. Okay, I am skipping steps. Yes. Now alpha plus beta plus gamma, if you try with the method, you will get x square term. This is also 6. The point here is you got three numbers, three positive numbers, which product is 6 and with sum also 6. Yeah. So now first of all you need to admit that if the product of three number is 6, which is integer, and sum of the same values are also, that is also 6, an integer, that means definitely alpha, beta, gamma are integers. Integers means which has no decimals. Now the only pair of numbers which can satisfy this condition is 1, 2 and 3. Come on, 1, 2 and 3, because 1 plus 2 plus 3 is 6 and 1 into 2 into 3 is also 6. That's the only pair of numbers which can satisfy. So if you ask me to solve this equation and get the value of alpha, beta, gamma, I will say sorry, then you are in wrong exam practice. Yeah, if you are practicing, if you're preparing for this particular exam, then you need to be smart enough. Yeah, you can't always solve equation and get. You also have to be comfortable with numbers. Okay? Yes, and I know all my students are watching all my videos. I will make sure that you will be comfortable with the numbers. So yes, one of them. Be comfortable with the number. One of them. 1, 2, 3. That's the only pair which product is 6 and sum is also 6. Yeah. Let me use it here. So these are the alpha, beta, gamma I can directly say. Now question said find A. A is what? Coefficient of x. The coefficient of x is minus A here. And coefficient of x is what? Plus. See, plus sign. So that means here if I try to find alpha beta plus beta gamma plus gamma alpha, which is the coefficient of x, should get me the coefficient of x, which is equals to what? Minus A. That's how I can find the value of A. Did you understand this? Now if I substitute, I get 1 into 2. Yeah, 1 into 2. Product 1 into 2 is 2. Then 2 into 3 is 6. Then 1 into 3 is 3 equal to minus A. That is what? 2, 6, 8 plus 3, 11 equal to minus A. So A is equal to what? Minus 11. Okay. If I multiply them, then what am I going to get? Alpha into beta into gamma. What am I going to get? P minus Q into P plus Q. So Q into, see here, A minus B multiplied by A plus B. So that's going to be A square minus B square. So I'm just writing what are the possible relations so that I can compare and get the answer. Now here alpha plus beta plus gamma, the coefficient of x square and coefficient of x square. See, negative sign is same. So we can get rid of the negative and only write alpha plus beta plus gamma as 18 here, which is nothing but what? 2p plus q, that is equal to 18. The next question is this: if p minus q, p and p plus q, they are the roots of equation, a cubical equation, we need to find the value of p and q. I want you to pause this video and try solving this question and see whether we match. This question, we can say this question is of difficulty, level of difficulty 2, LOD 2. Let's see how do we solve this. Now, first you can see it's a cubical equation and they are talking about roots. So I should take the cubical equation in form of roots and then see, let's see what are we going to do with that. I don't know. But first of all, because they are talking about roots, let me write the equation. Let me take the cubical equation in form of roots and then understand. Well, here I have alpha, beta and gamma are roots, and as per the question, they are what? P minus Q, P and P plus Q. Correct? Now, what can we do with this given condition? Let's try some random things and see what do we understand. Well, what I see here, I got P minus Q and here P plus Q. So if I'm going to add these roots, I can get rid of q. It's leading somewhere. Yes, let's try this. So if I add all the roots, sum of roots, yes, so I can get this p plus p plus p is 3p and minus q plus q gone. Okay. Now looking at this, the sum of roots here. Here I can compare directly because the x cube, the coefficient of x cube is 1. So I can directly compare. I am getting rid of some steps. Okay, if you want me to write all the steps, I can do that, but please try to understand the shorter steps. So here I have sum of roots, which is coefficient of x square. Here coefficient of x square is minus 18 and this is also minus. So both signs are same. So I can get rid of the negative sign and say alpha plus beta plus gamma as per the given question should be 18. Now here I got alpha plus beta plus gamma is 3p. So I can say this is 3p equals to 18. So p equal to what? P equal to what? 6. Correct. P equals to 6. Okay. Then what do we do? Let's try with product. Alpha into beta into gamma. So here I have alpha into beta into gamma minus negative sign, and the constant of here is also negative, which is 162. So I can say alpha into beta into gamma as per the question, considering alpha, beta and gamma are the roots, I can say that is equal to 162. Now let's see what are we going to get by using p and q. See, this alpha is p minus q and gamma is p plus q. So if I multiply alpha, beta and gamma, I am removing steps. Okay, please understand. So alpha into gamma is going to be a minus b into a plus b, which is nothing but what? A square minus b square. Correct. So if I multiply 3, I can write the product of all 3 of them is going to be p into p square minus q square. Are you getting this? P, which is beta, and alpha into gamma is like a minus b into a plus b, the formula a square minus b square. Correct. Let me use it here. So alpha into beta into gamma, I can use it as p into what? P square minus q square. Now this is going to help you to get the value of q. We got the value of p with the previous relation. Now if you substitute p equal to 6 here, what you get? 6 square minus q square. Okay, now it's all calculation, and I know you are much smarter than me in calculating. So do the calculation. 6 square minus q square. Yeah, do it quietly. That is negative sign here. So this is q square, 27 here. This is 36 minus 27, that's 9, equal to q square. So q equal to what? Q equal to what? Square root. Yes, write plus minus 3. Okay, don't only write 3, it could be plus minus 3, anything. Okay, here. Okay, this is getting me plus minus 3. Q, we still don't have unique value of q. We have q equal to plus minus 3 when you take the square root. You can take the help of this part, the x coefficient, which is 99, to see whether you get this 99 with plus 3 or minus 3. Yeah, plus 3 or minus 3. Okay, so alpha beta, beta gamma and gamma alpha product, this is also positive and this is also positive, is equal to 99. That is going to, so don't blindly mark plus 3. Okay, don't blindly mark q value as plus 3, because when you to find q, you need to take the square root, and when you take the square root, you need to have plus minus sign with that. Yeah, so alpha beta, beta gamma, it could be plus 3. I'm not denying the fact. You have plus 3 or minus 3. It could be plus 3 also. I'm not denying the fact. But thing is, don't mark blindly, because it could be minus 3 also. So alpha is p minus q. Yeah, I will take the reference of what we have assumed here. And beta is what? Only p. P into p plus q. Okay. Here this is p plus q, and alpha is what? P into q. P minus q. Okay. Now that is supposed to be what? 99 as per the question given. Now let's try with plus 3, q equal to plus 3, and p is already we know, that's 6. So plus 3, q equal to plus 3. So 6 minus 3 is 3 into 6 plus 6. 6 plus 3 is 9. 6 plus 3 is 9. 6 minus 3 is 3. Okay, let's check whether we get 99. This is 18. This is 54. And this is 27. Add this. What do you get? 8, 12, 7, 9. Carry over 1, 2, 5, 2, 9. Yes. So you're getting this 99 when you consider q equal to 3. Now you can confidently say that q is equal to 3. Okay, so you got the answer. Q equal to 3 and p equal to 6. Oh gosh, you are solving level of difficulty 2. Keep it up, guys. So this is it in today's lecture. I will see you in the next lecture. My name is Shyam Manawat signing off. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.